Commander, let's light the sky. Training sharper drone pilots, learning how to fly. Mission ready mindset, safety leading every plan. Skills that build confidence from takeoff through the scan. Tune in at Sky Commander, come join the crew today. Learning smart, fly with purpose, level up your way. We see more, no sooner, that's the edge we're here to spread. See above, go beyond, get ahead.
Okay, let's get started.
So picture this. You are out in the field on a commercial drone flight, right? The landing is completely clean. The client is standing right next to you, and they are nodding. They are clearly thrilled with the result.
It's the dream scenario.
Exactly. You check your monitor, and the footage is just absolutely sharp. It is perfectly framed, catching that exact golden hour light that you promised them.
Right.
So you pack up those heavy Pelican cases, you load them into the back of your truck, and you log the job as a total success. I mean, it was a flawless mission.
On paper, sure, it looks flawless.
But if we actually pull back the curtain on what happened during that specific flight, the reality is entirely different, isn't it?
Oh, completely. Because beneath that shiny surface, there's usually a whole sequence of ignored warnings.
Right. Because you quietly admit to yourself that you actually lost situational awareness of the aircraft for like 12 seconds near an active service road.
Which is terrifying.
Because you were just staring at the camera feed.
Yeah.
And you skipped checking the NOTAMs, the notices to air missions, because, well, it was just a quick flight in an area you felt you knew really well.
You got complacent.
Exactly.
Yeah.
And to top it off, you completely ignored a battery voltage warning that was flashing on your screen. Why? Because the drone stayed in the air and, nothing bad actually happened.
Yeah. I mean, functionally, an operation like that is just a disaster waiting for a timeline.
Right.
We are looking at a deeply flawed process that just happened to get lucky today.
And that is the exact paradigm shifts we are anchoring this entire deep dive on today. A crash is not the start of a safety problem.
No, absolutely not.
A crash is usually the receipt.
Right.
It's the final bill coming due for this long chain of hidden risks that a pilot or an entire organization has been actively ignoring.
I love that phrasing. The receipt is a really, really accurate way to frame it.
Right.
In complex operational systems, whether we are talking about aviation, heavy industry, or even IT infrastructure, the consequence is almost always delayed.
So the system is telling you there's a problem early on.
Exactly. It gives you ample warning that things are degrading. But if you define your success solely by the absence of a catastrophe, you essentially train yourself to ignore those warnings.
Which brings us to our mission for this deep dive. We are going to equip you, the listener, with the analytical toolkit you actually need to measure true operational safety.
Because the standard metrics just do not work.
They really don't. We are synthesizing the core concepts from this incredible source material, Beyond the Crash, data-driven metrics for drone safety operations.
Specifically focusing on Sky Commander's analysis in that text, which really dissects safety metrics that reflect reality, not just the illusion of safety.
Right. And whether you operate a massive fleet of drones or manage a complex project team, or, you just want to understand how to evaluate risk in high-stakes environments, this discussion is going to completely reshape how you view success and failure.
We have to move past that superficial metric of, well, nobody got hurt today.
Right. We want to spot the systemic rot before it materializes into that final receipt.
And that shift in perspective requires moving from a completely reactive posture to a proactive one.
Because most organizations just wait for the crash.
Yeah, they wait for a very loud, very expensive failure to finally tell them their system is broken. But a mature safety culture is engineered to listen to the whispers of failure long before the shouting starts.
I mean, it makes me think about this analogy. Measuring safety by your crash count is basically like driving a car down the highway, but the only light on your dashboard is the airbag deployment sensor.
That is a great way to put it.
Right, because if that light finally turns on, you are already in severe trouble. You have already hit the tree.
Exactly. The airbag sensor only confirms that the worst-case scenario has already concluded.
It's too late.
Way too late. It provides zero data regarding all the events leading up to the impact. It doesn't tell you that your brake pads are worn down to the metal or, that your tire tread is totally bald.
Or that you've been literally drifting across the center line for the last 20 miles.
Right. In drone operations or any high-reliability industry, tracking the number of crashes is necessary for historical record-keeping, sure.
You have to write it down.
You do. But as a management tool, it is completely insufficient. It is what safety professionals call a lagging indicator.
Because it's measuring something that is already in the past. Like it's the dent in the bumper.
Precisely. A lagging indicator measures the damage after the event has completely run its course. It might tell you what broke, but it offers almost zero predictive value for what might break tomorrow.
So if you aren't measuring the crash, what exactly are we supposed to be looking for?
Well, if an organization worships that crash count as their primary metric, they are navigating by looking exclusively in their rearview mirror.
Which is terrifying.
It is. You might see a small remote pilot team fly, say, 300 missions over 6 months without a single crash.
And management probably loves that.
Oh, they do. Management hands out bonuses. They boast to their clients about their pristine safety record. Everyone feels very comfortable. But beneath that surface layer of success, they are quietly institutionalizing unsafe habits.
Like what? What are they actually doing wrong if they aren't crashing?
Well, rushing through pre-flight briefings because they feel redundant, for one.
Oh, right. We already know what we're doing.
Exactly. Or maybe pushing aging lithium-ion batteries way past their safe life cycle just to save a few bucks on hardware replacements. Or using stale site maps that don't show the new power lines that were installed last month.
Or another example from the source, utilizing their visual observers as production assistants.
Yes, that's a huge one.
Because their sole job is to scan the airspace for intruding aircraft or ground hazards, right?
Right, but instead the team has them carrying gear or checking the video feed instead of watching the sky. And if you do that long enough, eventually the aircraft encounters an unexpected wind gust.
Or some sudden electromagnetic interference.
Or a helicopter drops below the hard deck right into your operational volume. And the final incident report will probably call it an unforeseeable, sudden tragedy.
But it wasn't unforeseeable at all.
Not even a little bit. A forensic look at their daily operational data would have shown a slow, highly predictable drift right toward that disaster.
So to visualize how we should actually be looking at this, the text talks about a safety pyramid.
Yes, the safety pyramid is crucial here.
Right. So at the very apex of this pyramid, you have those high consequence, highly visible events. The crashes, the injuries, the severe property damage.
The regulatory action from the authorities.
Exactly. That tiny point at the top is what everyone looks at. It's what the media cares about. It's what the lawsuits are built on.
But that apex actually rests on a much, much wider middle layer.
Okay, so what lives in the middle of the pyramid?
The middle is populated by events that are frequent, but perhaps slightly less severe. Things like near misses with other aircraft, flyaways where the drone momentarily loses its command link but recovers.
Oh, wow. So instances where the aircraft exceeds the planned operational boundary but doesn't hit anything.
Right. Or unstable landings where the drone tips over but doesn't shatter into pieces.
So these are those moments where the pilot's heart rate totally spikes, but they somehow manage to get the hardware on the ground in one piece.
Yes. The margin for error basically shrank to absolute zero, but they got away with it. The system bent, but it didn't entirely break.
Okay, but the true predictive power isn't in the middle either, right? It lies at the massive base of that pyramid.
It does. This foundational layer consists of the daily friction points. These are the hazard reports filed by the crew members. Defects found during a routine pre-flight checklist.
Or pilots calling a halt due to fatigue.
Exactly. Or concerns about degrading weather patterns, minor voltage anomalies during a battery warm-up, gaps in the communication plan.
Or even instances where a client tries to pressure the crew to fly faster. All of that lives at the base.
And the fundamental theory here is that the base of the pyramid always moves first.
Right. Catastrophic failures rarely just materialize out of thin air.
Always. Long before a multi-rotor aircraft actually falls out of the sky, you will see a statistical spike in checklist omissions down at the base, or a steady increase in minor equipment warnings.
So good teams measure the base because it tells the future.
Exactly. Professional operations dedicate their resources to monitoring that base. If you can identify and mitigate the anomalies at the bottom, you effectively starve the top of the pyramid of the ingredients it needs to produce a crash.
But, to effectively measure that pyramid base, we first need to make sure we are using the right words to describe what we are actually seeing.
Vocabulary is absolutely everything in safety.
Right, because if an organization is tracking these anomalies, they need a highly specific vocabulary. The source mentions that aviation authorities mandate an SMS, a safety management system.
Yes, like Transport Canada or the FAA in the U.S.
Right. And Transport Canada defines an SMS as this documented framework designed to manage risk, identify hazards, and ensure corrective actions are implemented.
The FAA has very similar language, calling it a formal top-down approach. But here is the thing. An SMS is just a heavy binder full of paper if the crew out in the dirt doesn't understand the basic terminology.
I totally agree. And the text really methodically unpacks this. We already established that a lagging indicator is the dent in the truck.
Right, the event that already happened.
But the opposite of that is the leading indicator. So going back to our car analogy, this would be the blind spot warning system beeping rapidly before you actually merge into the other vehicle.
It's the smell of smoke before you see the visible fire.
Exactly. So leading indicators are proactive.
Yes. For a drone operation, a leading indicator might be the percentage of flights where the crew actually completed a comprehensive pre-flight briefing, or the number of proactive hazard reports submitted to management before a mission launches.
Or maybe tracking the number of batteries proactively retired from the fleet because they hit a certain cycle count.
Exactly, instead of waiting for one to fail mid-air.
But I have to push back a little here as a curious learner. Counting how many safety briefings a crew holds feels a bit hollow to me.
How so?
Well, just because 4 people stood in a circle and talked for 5 minutes doesn't mean the flight is actually safer. I mean, they could have just been discussing where to get lunch.
That is a brilliant point, and it highlights a really vital caveat regarding leading indicators. A metric is only valuable if it correlates with an actual change in behavior or system health.
So tracking the mere occurrence of a briefing is just a weak metric.
Exactly. It measures compliance, not effectiveness. If a much stronger leading indicator is tracking the number of briefings that resulted in a tangible change to the flight plan.
Oh, like, did the briefing actually uncover a hazard?
Right. Did it cause the crew to alter their launch location? Did they delay the flight for better weather? Did they change their emergency return altitude? That demonstrates a leading indicator functioning as an active defense mechanism.
That makes so much more sense. Okay, let's talk about 2 words that get thrown around a lot. Aren't hazard and risk just 2 words for the exact same thing? Because I hear them used interchangeably all the time.
It is a pervasive conflation. Everyone mixes them up. But in the realm of safety science, they describe fundamentally different aspects of reality. Understanding the distinction is non-negotiable.
So break it down for us. What is the difference?
A hazard is a condition, an object, or circumstance that possesses the intrinsic potential to cause harm. It is simply a trap waiting for the right timing.
So if I'm on a job site and I see a loose propeller on the drone, the loose propeller is the hazard.
Correct. It exists regardless of what you do about it.
Okay, what about a moving crane near my flight path?
Also a hazard. A degrading GPS signal environment caused by a solar flare? Hazard. Pilot fatigue after a 14-hour shift? Hazard.
Or an aggressive client demanding you fly faster?
Absolutely a hazard. These elements just exist in the environment as latent potentials for destruction. Risk, conversely, is the mathematical calculation applied to that hazard.
Okay, so risk is the math.
Yes. Risk asks 2 sequential questions. What is the probability that this hazard will manifest into an actual event? And if it does, what is the severity of the consequence?
Okay, let's use an example from the source to clarify this. Let's take a standard commercial drone, like a 10-pound quadcopter, and we fly it over a completely deserted agricultural field in perfectly calm weather.
Okay.
The hazard of a total motor failure absolutely exists, all right? The manufacturing defect might be sitting right there in the copper winding.
Yes, the hazard is present.
But the risk profile is relatively low because the likelihood is remote and the severity is minimal.
Right.
I mean, if it drops out of the sky, it destroys a few stalks of corn and the drone itself.
Right. Now, take that exact same drone with the exact same motor hazard and fly it at a busy intersection in downtown Manhattan.
The hazard hasn't changed at all. It's the identical object.
But the risk profile has increased exponentially. The likelihood of an incident might increase due to dense radio frequency interference in that urban canyon, which messes with your command link.
And the severity skyrockets.
Exactly. An uncontrolled descent over a crowded intersection involves pedestrians, moving vehicles, reflective glass facades. The hazard is static. The risk is dynamic.
That is a huge distinction. So once a crew identifies a hazard like that dense urban environment, and they calculate that the risk is unacceptably high, they don't necessarily just pack up their gear and go home.
No, they apply what safety manuals call controls.
Which are essentially the guardrails, right?
Exactly. A control is a specific barrier designed to interrupt the pathway between the hazard and the consequence.
So establishing a physical exclusion zone, using high visibility cones to keep pedestrians away, that's a control.
Yes. Requiring a secondary visual observer to monitor a blind spot is a control. Implementing a hard operational limit like no flying if the wind exceeds 15 knots is a control.
But just having the control written down in a binder doesn't mean anything if the crew ignores it in the field.
Which is why we evaluate control effectiveness. A control that exists only on paper is purely decorative.
It's just the illusion of safety.
Exactly. You must measure whether the barrier actually functions when tested. If your control is a pre-flight checklist, a weak metric simply tracks that the checklist was signed.
Right. Anyone can scribble a signature.
But a metric evaluating control effectiveness tracks how many critical defects that checklist actually caught before takeoff. If it never finds a defect in 1,000 flights, your crew is just pencil whipping the form.
Wow. And that brings us to this concept of residual risk. Because even with the best controls in the world, the risk doesn't just evaporate.
No, it never drops to absolute zero. Residual risk is the threat level that remains after you have successfully implemented every reasonable control.
So if your hazard is an unauthorized person walking under the drone,
Yeah.
you set up your barricades, you assign a guard, you wear high-vis vests.
You make loud verbal announcements before descending. All of that drastically reduces the likelihood.
But the residual risk acknowledges that someone wearing noise-canceling headphones, staring at their phone, could still just walk right past the barricades.
Exactly. Acknowledging residual risk prevents a crew from becoming complacent. They know the armor has gaps.
And complacency is what drives arguably the most insidious concept we are going to talk about today.
Drift. Drift is fascinating and terrifying. It is the silent, incremental departure from established safety baselines. It's how abnormal, risky behavior slowly becomes normalized.
It's so recognizable in almost any professional setting. Like, think about a new crew starting a major infrastructure contract. Month one, their adherence to protocol is immaculate.
Oh, perfect 20-minute site briefings before every single launch.
They review weather, airspace, rally points, battery health. But fast forward to month three. It's routine now. The briefings start shrinking.
Right, they only do the full review if the site looks complicated.
And by month six, the formal briefing has just evaporated entirely. The pilot looks at the visual observer and says, "We all know the routine," and they just launch.
And the scary part is, no one views this as a deliberate safety violation. From the inside, drift just feels like efficiency.
It feels like gaining mastery.
Yes. It feels like shedding unnecessary bureaucratic friction. But what is actually happening is the systematic dismantling of the pyramid's base.
The controls are just eroding away.
And drift doesn't announce itself with a warning siren. It operates through quiet rationalization. If you lack a mechanism to actively audit for drift, you won't see it until a catastrophic failure happens.
So once a team actually has this vocabulary to identify a hazard or observe drift, they need a place to put that data so it actually changes behavior.
They need a dashboard, a mission control dashboard that actually works.
Right. Because words alone do not manage an operation. If I'm the chief pilot of a 20-person fleet, I can't just hope they remember these definitions. I need to aggregate the data and visualize it.
A safety dashboard serves as the central nervous system for an operation. But there is a profound difference between a functional dashboard and a data dump.
Oh, I've seen the data dumps.
Yeah.
It's a sprawling mess of 30 different charts that nobody trusts.
Exactly. Middle management looks at it once a quarter. It creates noise without generating insight. A highly effective dashboard is minimalist. It focuses on a highly curated set of metrics like 6 to 8, designed to trigger action.
And the source outlines the architecture for this perfectly. It categorizes the metrics into 5 families.
Right. Exposure, control health, weak signals, outcomes, and learning metrics.
Let's start with exposure. If I'm building this, why do I start there? What does tracking total flight hours actually tell me?
Exposure metrics quantify the volume of risk the organization has absorbed. They answer a fundamental question. How many opportunities do we give the hazards to manifest?
Okay, so total sorties, battery cycles, operations near people.
Right. On their own, they don't indicate if you are safe or dangerous. They just define the size of the arena. But their true value is providing the mathematical denominator for every other metric.
We will definitely come back to the power of that denominator because it is crucial. But first, let's look at the second family, control health metrics.
This is the system verifying that the armor is actually being worn. Are the guardrails functional?
So tracking the completion rates of crew briefings.
Or analyzing the percentage of flights where geofence limits were properly established prior to launch? It's a measurement of procedural discipline.
Then the third family is where we start looking for the whispers. weak signal metrics.
This maps directly back to the base of our safety pyramid.
The friction points.
Exactly. Weak signals represent the system experiencing stress before a failure occurs. The volume of hazard reports, minor GPS degradation, battery voltage sag, or external pressure from a client.
These are the leading indicators begging for intervention. And if a team ignores them, they graduate to the fourth family, outcome metrics.
As for the lagging indicators, the crashes, property damage, airspace incursions, outcome metrics document the failures that the preceding three families failed to prevent.
And the final family is learning metrics. This measures the organization's capacity to evolve. Are we fixing the root cause or just treating symptoms?
A critical one here is the repeat hazard rate. If a pilot reports radio tower interference, and 2 months later another pilot reports the exact same interference at the exact same tower.
Your learning metric just failed.
Exactly. The corrective action system is broken. The data was collected but never translated into a systemic control, like an exclusion zone in the dispatch software.
I love how clear that is. And I want to jump in with a mnemonic from the text that really struck me regarding how a business measures success versus how a safety system measures health.
The KPI versus SPI dynamic.
Yes. Because in the corporate world, everyone talks about KPIs, key performance indicators, tracking revenue, completion times, efficiency.
Right.
But in aviation, we talk about SPIs. And the text calls an SPI a safety pulse indicator.
That's a great way to remember it.
And there's this fascinating trap here. A poorly designed KPI can actively destroy a safety culture.
Oh, absolutely. A KPI is fundamentally designed to exert pressure on a system to increase output. An SPI is designed to monitor the health of the system under that pressure.
So if a mapping company has a KPI that dictates every pilot must complete 10 infrastructure sites per day to hit revenue targets, that looks great on a spreadsheet.
But out in the field, it's a relentless psychological force.
Right. If a pilot is on their 8th site, the sun is going down, the wind is picking up, and they notice a minor defect on a propeller, the KPI is screaming at them to ignore the defect, skip the checklist, and just launch to hit the quota.
The business goal is accidentally incentivizing dangerous behavior. It's a classic misalignment.
So how do you fix that?
You constrain the KPI with an SPI, you redesign the metric. The goal is no longer simply complete 10 sites per day. The revised metric becomes complete plan sites per day without incurring any unresolved safety deviations.
That is such a subtle shift, but it changes everything.
It fundamentally alters the incentive structure. It tells the pilot that productivity is required, but never at the expense of procedural integrity.
It gives them institutional backing to halt an operation when a hazard emerges.
Without fearing they will be penalized for missing a blind quota.
Amazing. Okay, let's go back to the power of the denominator. You mentioned earlier that exposure metrics serve as the denominator. Let's dig into the math of why a metric without a denominator is virtually useless.
A raw number is just an isolated anecdote. It lacks scale and context. We call the solution rate-normalized metrics. You must divide the negative event by the volume of exposure to understand the actual frequency.
So let's use the lithium-ion batteries example from the text. A pilot reports to maintenance. We experienced 5 battery voltage warnings this week.
Right.
If I hear that without context, I assume we have a severe hardware crisis. 5 warnings sounds terrible.
But you cannot determine the severity without the denominator. If the fleet experienced 5 voltage warnings out of a total of 10 flights.
Then you have a 50% failure rate. Ground the fleet immediately.
Exactly. But if those same 5 warnings occurred over the course of 5,000 flights, the failure rate is statistically microscopic. The hardware is performing exceptionally well.
So a rate-normalized metric is crucial. But a world-class dashboard doesn't stop there, right? It layers context over the math to force a decision.
Yes, 5 battery warnings is bad data. 5 battery warnings per 200 cycles is better.
But what if it's 5 battery warnings per 200 cycles, all occurring on battery packs exceeding 18 months of age and all happening on cold mornings?
Now you have a clear decision to make. When data is structured with that level of granularity, it ceases to be just a number. It becomes an operational mandate.
Because the chemistry of lithium polymer batteries is highly affected by cold and age.
Right. Internal resistance increases as the temperature drops, compounded by chronological age. When the pilot demands high amperage, the aged battery can't deliver, resulting in voltage sag.
And Because the dashboard isolated the context, management doesn't have to guess. They immediately mandate a pre-flight warming procedure for cold environments, and they retire any batteries older than 18 months.
The weak signal was intercepted before a drone fell out of the sky.
Okay, I have to ask you about my favorite part of the source text, the golden metric.
Oh, yes.
Please reveal the ultimate metric, because when I first read this, it felt completely counterintuitive to everything I thought I knew about safety.
The golden metric measures a very specific operational reality. It tracks the percentage of missions where the safety system actively forced a change to the mission profile prior to launch.
See, my initial instinct is that a perfect safety system means everything runs exactly according to the initial plan. No deviations.
And that metric argues the exact opposite. Expecting a flight plan to survive contact with reality without requiring adjustments is a fantasy. The real world is dynamic and chaotic.
So a safety system that never alters a plan is probably just a system that is being ignored.
Exactly. If your dashboard indicates a healthy percentage of missions being adjusted before takeoff, it proves your safety mechanisms, your hazard ID, weather analysis, equipment checks, are actually functional.
It proves the safety process is not just decorative theater.
Right. The data being gathered by the crew is actively overriding the momentum of the schedule.
So a mission change could be relocating the launch pad because the wind shifted, or swapping out a slightly swollen battery, or pausing for 20 minutes because of pedestrian traffic.
Yes. Each of those represents a human being observing a weak signal, processing the risk, and choosing to alter the future. The golden metric proves your safety culture is alive.
But, and this is a massive but, an incredible dashboard is entirely useless if the people using it are too terrified to report their mistake.
Oh, absolutely. System design is irrelevant if it ignores human psychology.
Which brings us to the human element, culture. Safety is executed by individuals who face fatigue, schedule pressure, ego, and fear of reprisal. The text makes a rigorous distinction between safety culture and just culture.
Yes. Safety culture is essentially what happens when the manual is not watching.
The gap between the laminated checklist and the muddy launch pad.
Exactly. It's when a pilot voluntarily halts an operation due to a hazard, even if it causes a delay, because they value risk mitigation over productivity. But you cannot mandate that into existence. It grows in the soil of a just culture.
The culture of justice. Forgiving honest mistakes while holding reckless behavior accountable.
Right. It acknowledges that competent professionals will make mistakes, and sometimes the system sets them up to fail. An honest error is a learning opportunity.
But they must still hold individuals accountable for willful violations, like flying intoxicated or disabling a geofence.
Exactly. The line must be clear.
Let me ask you about myth number 2 from the text. Counterintuitive data. If I implement this just culture, and tomorrow my desk is buried in hazard reports, doesn't a sudden spike in hazard reports mean my operation is getting worse?
That is the most common and destructive trap a manager can fall into. You have to interpret the data through psychology. In a weak culture, reports are low because people hide their mistakes to protect their jobs.
So a spike in reports actually means they finally trust the process.
Yes. The operation didn't become more dangerous. It simply became visible. The blindfolds came off.
That makes so much sense. Now let's talk about protecting the pilot from external pressure. The clients. The text highlights what it calls the most dangerous sentence in client work.
Can you just get one more quick shot?
Oh man, every commercial pilot knows that sentence. You've spent hours planning, surveying, executing. You land safely. And the client points to a busy highway intersection a quarter-mile outside your operational volume and says, hey, while the drone is out, just pop it up and grab a quick overhead. It'll only take 2 minutes.
It is a profound test of operational discipline. That intersection was not in the site survey. The risk assessment didn't account for the fast traffic or the uninvolved pedestrians.
But human nature wants to accommodate the client. You want to be helpful.
Right, and if you just say, no, it's not safe, the client interprets that as you being difficult or bureaucratic.
It creates interpersonal friction. So I love the takeaway here, the one more shot defense. You use the dashboard to sound professional.
You externalize the authority. You say, our dashboard actively tracks flights outside approved scope. I cannot launch without updating the risk assessment for that intersection and logging the new parameters.
It instantly turns an emotional conflict into a systemic boundary. The client respects that you are managing their liability as well as your own.
Exactly. It's brilliant.
So theory and culture sound great, but to see how this friction actually plays out in the real world, let's open up the case files provided in the source material. theory meets reality.
Scenario analysis is where this framework really proves its worth. Let's look at case file 1, the perfect flight with the ugly metric.
Okay, set the scene. You are the pilot for a thermal roof inspection. The flight is smooth, imagery is pristine, client is ecstatic.
But during debrief, you acknowledge 3 deviations. 1, the client walked past the cones into the landing zone. 2, you skipped the formal crew brief because you flew this building 6 months ago. 3, a momentary compass error flashed near an HVAC unit.
In a primitive culture, you just log 100% success and move on.
Which results in total data loss. The takeaway. A clean landing does not erase a weak process. The absence of a crash is just luck masking drift.
So the pilot has to log the client encroachment as a near miss, the compass warning as a technical weak signal, and the omitted brief as a procedural deviation.
Exactly. Otherwise, next time the client might walk into the propellers or the drone might hit that electromagnetic field and fly away.
Case file 2, the whispering battery. You are flying utility poles. Battery B07 shows mild voltage sag twice, but the pilot keeps flying because it still works.
This is terrifying because lithium-ion chemistry is unforgiving. A warning isn't a suggestion, it's data with a countdown clock.
Repeated voltage sag means the battery is converting energy to heat. If you push it hard, the voltage collapses, the controller reboots, and the drone falls.
The required action is physically quarantining battery B07 immediately for analysis. Catch it at the base of the pyramid.
Case file 3, the VO who became a photographer. You have a visual observer assigned to watch for ground traffic near an industrial yard.
But the VO gets complacent, steps behind the pilot, and starts offering framing suggestions on the monitor.
And a large delivery truck enters the zone unannounced. The drone doesn't hit it, but the margin of safety evaporated.
This is a failure of control effectiveness. The guardrail was written down, but abandoned. A VO is a safety control, not a spare set of hands.
You have to pause operations, do a hard reset, and log the roll drift.
Exactly. Finally, case file 4 or 5 in the text, the tree clip. A drone clips a thin branch during an automated mapping grid.
The pilot lands, sees minor scuffing on the prop, and because they are behind schedule, they just want to swap the props and keep going.
And this collides with strict regulatory reality. Looks fine is not a return to service standard. The impact sends shockwaves through the carbon fiber arms, potentially causing microscopic stress fractures in the motor mounts.
And it violates Canadian regulation SIRE 901.49, right?
Yes. SIRE 901.49 mandates that if an aircraft experiences an unanticipated damage event, you must cease operations immediately. You require a full operational pause and a root cause analysis before flying again.
Because if you just swap the props, you might launch a structurally compromised drone.
Exactly. These case files really show why metrics have to scale with the operation.
Which brings us to scaling complexity and evolving regulations. I have a skeptical question. If a listener is just a solo pilot doing basic rural photography, isn't all this dashboard stuff just massive corporate bloat?
That is myth number 4, and it is strongly refuted. A solo pilot absolutely needs metrics because human memory is deeply unreliable.
Right, you aren't going to remember which battery sagged 3 months ago.
Exactly. And clients expect defensible evidence, but the metrics must match the complexity. Basic visual line of sight, VLOS needs checklist, and battery logs.
But if you scale up to advanced urban or BVLOS beyond visual line of sight, the physical risk profile changes completely.
When you can't see the drone, you depend entirely on your digital command link. So a BDLOS dashboard must track command link performance, latency, public encroachment, and autonomous loss link behavior.
And the regulatory bodies know this. Let's look at the 2025 Canadian RPAS modernization, SOR 2025-70.
Transport Canada introduced the RPOC-RPAS Operator Certificate and Level 1 Complex Pathways for BVLOS.
And the mindset shift there is massive. It went from, I have a certificate and didn't crash, to, I can prove my procedures work.
Through Standard 922. It demands documented empirical evidence that your safety procedures function before you launch.
The US FAA is doing the same with Part 107, operations over people, night operations.
Removing the waiver requirement doesn't remove the physical hazard. You still have to track crew training for night physiology.
And remote ID compliance.
Yes, remote ID is a vital dispatch blocking metric. If that digital license plate isn't broadcasting, the flight is scrubbed. No residual risk allowed.
We have covered so much ground today, the vocabulary, the dashboard, the culture, the case files, the regulations.
It's a comprehensive methodology.
And to synthesize all of this, the core lesson of the source material is that we have to stop measuring safety by asking, did we crash?
Yes. We must start asking, did our system catch the next problem early enough to change the mission? And as a final takeaway, I want to leave the listener with the 5D bad metric detector from the text. Run your metrics through this checklist. Is your metric decorative, delayed, disconnected, difficult, or dangerous?
Decorative, delayed, disconnected, difficult, dangerous. I love that.
It strips away the corporate noise.
It really does. So to wrap this up, I want to address you, the listener, directly with a final provocative thought to mull over.
Building right on that concept of drift.
Exactly. Look at an area of your own life or your own work where you are currently experiencing a 100% success rate. Everything looks perfect.
The landing is clean.
Right. Are you succeeding because your system is actually bulletproof? Or are you just like that drone pilot on a quiet flight where your specific combination of hidden risks simply hasn't found the right timing to become a receipt yet?
That's a wrap on today's mission, Commander. See above, go beyond, get ahead. For more training, tools, and intel, head to skycommander.ca. If you learned something new, share it, subscribe, and leave us a 5-star debrief.